Hello, today we're doing the second part of lesson 8.4. We're going to multiply and divide rational expressions. We're going to start with multiplication. Now when we multiply rational expressions, it's the same as multiplying fractions because fractions are rational expressions. So let's take a look at this property. If I have two fractions that we're multiplying, we're going to multiply the numerators and then we're going to go ahead and multiply the denominators. And ultimately, if we have any common factors, we're going to divide those out. So let's just go ahead and get started with some practice examples. Okay, this one. Notice there's no plus or minus sign. That makes it kind of easy. So in this case, when there's no plus or minus signs, I'm going to go ahead and multiply the numerator together. So 3 times 6 is 18. X to the 5th times x is x to the 6th. Y squared and y squared is y to the 4th. Then in the denominator, we multiply 8 times 9, we get 72. X times x cubed is x to the 4th. Remember, we add our exponents, and y times y is y squared. Now I'm going to go ahead and divide out any common factors. 18 does divide into 72 evenly with a leftover of 4. When I'm dividing like bases, remember I subtract exponents, so I have 6 minus 4 is 2. We put it where the bigger exponent is. 4 minus 2 is 2. We put it where the bigger exponent is. So my final answer for this problem would be x squared over y squared. I'm sorry, x squared times y squared over 4. So this is nothing new. We've done this. We did this when we did our exponent unit. Okay, now here's more what we're talking about in this unit. If anything can be factored, factor. Do not multiply it out, then try to factor it. So I just actually look at it separate. I'll look at this term. Is there anything I could factor? Yes, I can take a 2x out. So I'm left with x minus 5. Now, I'm just going to go ahead and write this, x plus 3. Okay, in the denominator, is there anything I can factor? Yes, I have difference of squares. So I'm going to do x minus 5 times x plus 5. And then I'm going to go ahead and just write this, 2x squared. Now we're going to cross off any common factors. So I know I can see right away I have an x minus 5. I can divide out the 2's. Now I have an x by itself and an x squared. So I'm going to divide that out and I'm going to be left with an x on the bottom. Now rewrite what you have left. So in the numerator I'm left with an x plus 3. And in the denominator I like to write what is not in a parenthesis first. So I have x times x plus 5. And like I said in the last section, we don't need to re-multiply this out. You can go ahead and leave our answer like this. Ultimately, the reason is because if it wasn't factored, you want to make sure you have it factored to see if there were any common factors that could divide out of the problem. Okay, let's go ahead and try these next two. So like I said, we're not going to multiply and then start factoring. We're just going to look at every term separate. So I'm going to factor this. Now, this one, I want us to remember our rules of factoring. I like to write them in descending order, so I'm going to write it as negative 3x squared plus 3x. Remember, if it leads with a negative, I would like you to factor out that negative. So I'm going to factor out a negative 3x. When I do that, I'm left with x minus 1. Now I'm going to go ahead and factor this. This is a trinomial with a lead coefficient of 1. So it multiplies to give me negative 20 and adds to give me positive 1 would be positive 5 and negative 4. So this whole thing is all in my numerator. Now I'm going to go ahead and do the denominator. So what multiplies to give me a negative 5 and adds to give me a positive 4, that would be x plus 5, x minus 1, and then we have a 3x on the bottom. Okay, so let's cross off any common factors, x minus 1, x plus 5, a 3x, and a 3x. Now be careful. You are left with a negative 1 there. So the numerator, I have a negative 1, or negative, times x minus 4. I will accept this as the answer, or some people want to multiply it through. You don't have to. It would be negative x plus 4. Either one of these would be correct. And like I said, I'm perfectly fine with you leaving it the first one because that's what we've done. We've left our answers as factored answers. Okay, number 4. I can't do anything with this, so I'm just going to write it as x plus 2. Now this, if there's no denominator, it's over 1. So is there anything that multiplies to give me a positive 9 and adds to give me a positive 3? No. So I'm going to go ahead and just leave it. Now, you might not remember this, but this is difference of cubes. So when we factor this, we're going to put, remember when we do this, we cube root, we have our x cubed, and we cube root it. We're left with our a term to be x. And when we have 27 and we cube root it, we're left with our b term to be 3. Okay, now the first parenthesis when we factor a difference of cubes is our a and b term, so x and 3. The second parenthesis is when we take a and we square it, so x squared. We take b and we square it, so we get 9, and then our middle term is a times b, which is 3x. And if you remember, our signs are SOAP. Same as the original, opposite of the original, always positive. Look what cancels out. Those two. So what are we left with? An x plus 2 over x minus 3. So that one we had to go back and remember how do we factor difference of cubes. So make a little note to yourself in case you need to refer back to this one for any U-tries, studying for quizzes, tests, anything like that. Now I do have a U-try. I want you to try this one on your own. Go ahead and pause the video. So the first one we're going to factor by difference of squares, easy AC factoring, GCF, and easy AC factoring. So go ahead and give that one a try, and then let's move on to division. Okay, when we're dividing rational expressions, we're going to do the same thing as when we divide fractions. So when we divide fractions, we leave the first fraction alone. We change the sign to multiplication, and we flip the second fraction. That's what we're going to do. So what I do is I will do that as I factor the problem. And you'll see what I'm talking about as we go ahead and do the examples. Okay, so here's what I'm going to do. This is my numerator. There's nothing I can factor there. I'm going to leave it alone as 4x. Now normally when I'm doing division, I'll change the sign to multiplication and I'll flip the fraction. So instead of me writing it and rewriting it, I'm just going to go ahead and factor this and put it on the top. So it multiplies to give me a positive 8 and adds to give me a negative 6, would be negative 4 and negative 2. Okay, so I'm done with those. Those are now my numerators because this was a division problem. Now I'm going to factor the denominator. So this problem I'm just going to take out a 5. And then this problem I'm going to take out an x. I'm going to divide out any common factors, which would be x minus 2, x minus 4, and an x. So this problem, you're left with just 4/5. Okay, so you see how I did that? If you're not comfortable doing that, then for number 2, go ahead right now, leave this first fraction alone, change the sign to multiplication, and flip the second fraction, and then start factoring it. Okay, I'm going to go ahead and leave my numerator. I know that this is going to be flipped, so this is going to end up being a numerator. What multiplies to give me 30 and adds to give me negative 11 would be negative 5 and negative 6. Then in my denominator, I'm going to go ahead and factor this just by GCF. And then I'm going to factor this by taking out an x. So notice this is very similar to the one I just did. Our x minus 5s cancel, our x minus 6 cancels, our x's cancel, and I'm left with 7 halves. Okay, let's go ahead and try another problem. Now, when there is no denominator, we put it over 1. We're still going to do change the sign to multiplication and flip the fraction. Now this one is our longer AC factoring. So we're going to multiply 6 times negative 15, you get negative 90. What multiplies to give me negative 90 and adds to give me a positive 1 would be 10 and negative 9. So I'm going to rewrite this by using my middle terms. I'm going to go ahead and do GCF of these two, which would be a 2x. I'm going to take a GCF of these two. Remember, if it leads with a negative, divide out a negative. So I'm going to take out a negative 3. I'm left with 3x plus 5. You'll know if you didn't do a sign right because your parentheses won't be equal to each other, and they need to be. So I'm going to write my numerator as 3x plus 5. I divided that out, I factored that out. And then I'm left with 2x minus 3. Now, the second fraction flipped, so I have a 1 on top. So I don't need to write times 1. If you want to, just to remember that you did it, that's fine. Now on the bottom, there's nothing I can do with the 4x squared. This one, I can go ahead and take out another x. And then I'm left with 3x plus 5. So the 3x plus 5 cancels. The numerator, I have a 2x minus 3, and the denominator, I have a 4x cubed, because you have an x squared times x. You cannot cross any of these off because of the minus sign. Okay, the only time you can divide out terms is if everything is written in multiplication. Okay, I would like you to pause the video, try the try on your own. We'll discuss it tomorrow in class. And then if you have any other questions, comments, or concerns, go ahead and write it on the bottom of the paper, and I'll see you tomorrow.